Welcome back, ladies and gentlemen, to question number 16 on the Fermat paper from the year 2003. So what does this question have to say? The product of the digits of a 4-digit number is 810. If none of the digits is repeated, the sum of the digits is... I think this question was on the Cayley of the Pascal. I seem to recall doing a question like this a little while ago. Product of the digits of a 4-digit number is 810. None of the digits is repeated, the sum of the digits. So, it's not really about the 4-digit number here. Right, we just have 4 single-digit numbers. So, 4 numbers between 0 and 10. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 4 of them. They're all distinct. Their product is 810. Their sum is what? Okay. So, when I consider a question like this, first I've made the point that the 4-digit number part really isn't what's important. It's just that we have 4 numbers, they're distinct, and each one is between 1 and 9 inclusive. So, I know that their product is 810, I don't know their sum. But if I know the product is 810, I might grab my pen and start factoring 810 and seeing, can I get 4 distinct single-digit factors for 810? Looking at it immediately, I'm seeing 81 is a factor, because it's 81 times 10. And so 3 and 9 should be factors that I can consider here. Okay? So, what else can we do here? Well, let's factor it out and see if anything particularly jumps at me. So we have 810, and as I said, I can immediately see this is 81 times 10. Now the 10 breaks down into a 2 and a 5, and the 81, that's 4 copies of 3. That's 3 times 3 times 3 times 3. So we factored this thing. So already I'm seeing 3s, 2s, and 5s. Now if I start thinking about numbers, A, B, C, and D, and I multiply them together and I get 810, and I know that 1 is between... Actually, I could say A is the smallest, actually, because they're all distinct. So I can just say A less than B, less than C, less than D, less than or equal to 9. Okay. So when I see something like that, I think, gee, there's this factor of 10, and that leapt out at me immediately. I saw that in a snap. How do we get a 10? There's no way we can have, like, A be 10, or 20, or 30. There's no way to get the factor of 10 with a multiple of 10. So in particular, I think we have to have one of these numbers is a 5. Okay? Because 810 obviously is a multiple of 5, and every other multiple of 5, like one of the numbers will have to be a multiple of 5. Because 5 divides 810. So 5 divides A, B, C, D. So 5 divides 1, because it's prime, 5 has to divide one of A, B, C, or D. It could divide many of them, but then we'd have multiple factors of 5. But we need 5 to divide at least one of them, and there's only one factor of 5 in this range that will work. So one of the numbers has to be 5. Okay, so if one of the numbers is 5, 810 divided by 5 is 162. Multiply by 2 divided by 10. So we need 3 single-digit numbers that make this up, 162. So what are the factors of 162? Well, we still got that 2 there, and we have 4 3s. Okay. So could I have 2 by itself? If I have 2 by itself, if say A is 2 or B is 2, depending on whether or not A is 1. So say the first one is 2. And then I have to split 81 up into 2 factors And that means it's either going to go 81 times 1. There's no way that'll work. 81 isn't a single digit. 27 times 3, or 9 times 9. 27 isn't a single digit. Now you'd think this one would work, but we've got the same 9. And we were told in the question that these things have to be distinct. So there's no way I can just have 2 on its own. So that means I'm going to have to take at least one of these 3. In fact, it'll have to be one of these 3s, because if I take another 3, I'll have 2 times 9, and that's 18. So 6 must be a digit, as 2 won't work. 2 would leave 81, and there's no way to express 81 as a product of distinct single digits. So 6 must be one of the numbers. So we had 162, we divide it by 6, and we'll be left with 27, which is 3 to the 3. And lo and behold, if we take a look at factors of 27, we're down to 2, because the 5 is one digit, the 6 is another digit. We can have 27 times 1, or we can have 9 times 3. First one doesn't work, but you bet that second one does. Our digits are 5, 6, 9, and 3. And their sum is 5 plus 6, that's 11, plus 9, that's 20, plus 3. So we should be looking at a sum of 23. If we've done everything right, we should be able to find 23 in this list. And there it is right there. It is C. Now, the next question, that's question 17. I don't think I'll have enough space, so what I'm going to do is I'm going to flip the page in anticipation of that next question, and hopefully you guys will join me in the next video where we take a look at that one.